The computer chip industry has a problem. For nearly 60 years, a principle called Moore's Law has defined the industry's goals for the performance of integrated circuits. That's the fancy word for a computer chip. Integrated circuits need a variety of components to handle electricity and logic with purely electrical signals. But instead of just being a bunch of small components, they're packed into one tiny chip on a piece of material called silicon. Silicon is particularly special because it's a semiconductor. It can act as either a conductor or an insulator depending on what materials it is treated with. Or, most relevant to the world of computing, it can even be switched into a conductor by an electrical voltage. That means that silicon can be used to make a switch that works entirely with electricity. This component is called a transistor, and it works by placing a regular piece of silicon between two pieces which have been treated to be conductive. When an electric voltage is applied to the middle piece of silicon, charge can flow across it. By combining an array of these transistors, we can do mathematical operations and determine logic problems. In other words, we have a computer chip. Let's go back to the chip industry. Their goal is to make the fastest and most efficient chips possible. Shrinking the size of transistors helps with this in two ways. More small transistors can be packed into the same space, and they can usually be run faster since they output less heat. Moore's Law was made in 1965, and it predicted that the number of transistors in integrated circuits would double every 2 years. So far, we've met that goal. In 1965, a single integrated circuit had 64 transistors, and today we have integrated circuits with over 100 billion transistors. The issue is that we can't keep making transistors smaller. Today, the gap between the conductive pieces of silicon is as small as 3 nanometers, which is only 15 silicon atoms. At this size, electrons can sort of just disappear and reappear on the other side of the silicon, an effect called quantum tunneling. And there are a variety of other physics issues, much less to say about how hard it is to make the machines which make these transistors so small. Because of this, many people are predicting that Moore's Law will soon grind to a halt.